Today's lesson is 5.5 on multiple angle and product sum formulas. This lesson heavily uses your formula sheet, so I highly recommend you have it out, whether you have the built-in notes or not. Starting off, we have double angle formulas. These stem straight from yesterday's sine of u plus v. The only difference is someone said, what if they were both u? Hence, u plus u is 2u. You would still get the sine u, cosine u, sine stays the same, sine u, cosine u, sine u, in which case you would get 2 of the same thing, so that would give you 2 sine u, cosine u. Okay? Now, it becomes a lot more interesting with cosine. Not to say that this doesn't mean anything, but with cosines, because they're grouped together, we get cosine squared minus sine squared, which we could then either plug in a 1 minus cosine squared for the sine squared to give you a minus 1, double cosine squared, giving us 2 cosine squared minus 1, or we could substitute the other way, 1 minus sine squared first to get 1 minus 2 sine squared of u. This is the most beneficial one, and the rest of the formulas on your formula sheet stem from this. Starting off, solve the equation with exact values of 2 cosine of x plus sine of 2x. Now, previously we solved with something like sine of 2x. However, we're going to use the formula we just had. So we're going to substitute for this to give us 2 sine of x cosine of x, straight from the formula. And now that they both have the same argument, we can factor out. Right? So now they both have a cosine of x in them and a 2, so we can factor out 2 cosine of x. And the first piece is going to become 1, because if we divide by 2 cosine of x. Second piece is going to become sine. Right? That's the only piece that's left over. And now we can solve. 2 cosine of x equals 0. And then we have 1 plus sine of x equals 0. Solving each piece, where does cosine equal 0? Right, with unit circle in a second, cosine is 0 here and here. And then solving here, minus 1 from each side, we get sine of x equals minus 1. And that's only going to be where y is 0. So that answer is there. So our final answers are pi half, 3 pi half, and it's going to keep going. 5 pi half, 7 pi half. So we're going to get the odd pi halves, whereas over here you're only going to get 3 pi half, but you take both sets of answers. So we're just going to say x equals pi half, and then the pattern is plus 2 on the top, so plus 2 over 2 pi halves, which is pi, right? So we added 2 pi half to each piece. That's what we get. Plus n pi. There. Next, cosine of 2x plus cosine of x. Now, this one is the most flexible, right? We can plug in 2 cosine squared of x minus 1. We can plug in, right? We could also plug in 1 minus 2 sine squared of x. Now, because we already have a cosine of x, we want to plug in the cosine version, right? So now we're just plugging in 2 cosine squared of x minus 1 plus cosine of x. And now reorganizing this into standard form, we got cosine squared, 1 cosine, and then a minus 1. This is a factorable equation. So we're going to factor 2 times minus 1 is minus 2, adding to equal 1 cosine of x. And so our numbers are going to be plus 2 minus 1. And then we bring the 2 back. So we get 1. So cosine of x plus 1 is one of the parentheses. And the minus half is going to give us a 2 cosine of x minus 1 for our other parentheses. If you've got a question on how the factoring works, feel free to ask in class, or check out a factoring video for a not equal 1. And setting each piece equal to 0 now. Cosine of x plus 1 is 0. gives us cosine of x equals -1. The other side, we get 2 cosine of x equals 1, right? Plus 1 to both sides, and then divide by 2. So we get our answers are where does cosine of x equal -1, which is over here, and where does cosine of x equal plus 1/2, which is right here approximately. It is not plus or minus. So we're just going to have 2 sets of answers, because this is going to be pi plus the period of 2n pi, and then over here it's going to be the 1 pi third plus 2n pi. So there's our answers. Pi thirds plus 2n pi, repeats every period, and pi plus 2n pi, the odd number of pi's. Moving on, write the trig expression as an algebraic expression. Okay, so we've got sine of 2 sine inverse of x, right? This is just, again, fancy way of sine inverse of x, right? So we're just going to use the formula, right? Use the sine of 2x formula, which is going to give us 2 sine of x cosine of x. Well, this time, instead of x, the x's are sine inverse of x. So writing it in first, 2 sine of sine inverse of x times cosine of sine inverse of x. And this is not what they're looking for an answer. This is not an algebraic expression. This is a trigonometric expression, right? So if we want an algebraic expression, we need to solve. Now solving for, just a hint, whenever you see something like cosine of sine inverse, that's your hint we're going to make triangles. Again, sine inverse means drawing a triangle, we have some angle that has an opposite over hypotenuse equal to x. So my opposite is x, my hypotenuse is 1. Solving for my missing side, a squared plus x squared is 1 squared. Subtract x squared and square root, and we get that missing side is 1 minus x squared. And now we can find cosine of this angle and sine of this angle. So making it an algebraic expression, bringing down the 2, sine of sine inverse of x gives us x over 1. And then, so that was this piece. Next, cosine of this same angle here gives us adjacent over hypotenuse. So that gives us square root of 1 minus x squared over 1. And then simplifying, we get 2x square root of 1 minus x squared. Moving on, half angle formulas stems from that same original formula. Notice they all have cosine of u. They basically took cosine of 2x equals, no matter which one they have here, sine, cosine, whatever, right? We'll write the cosine one out for a second, right? Notice we went from 2x to 1x. So that's what they're doing here. They basically said, let's solve this piece for cosine, and that's what they did, right? Because now our argument goes from half u to positive u. Now, here is the biggest, most important part of this problem, which people get wrong all the time. The signs of the sine of u over 2, cosine of u over 2, depend on what quadrant the original piece lies. So if we're doing unit circle values, we might have something like, let's say we're doing sine of, let's say, 5 pi 12, or we'll make it, how about 7 pi 12, right? I can't figure that one out really easily with this, but this is equal to sine of 7 pi 6 half, and then we can use this formula up here. But what we need to do is consider what is the sine plus or minus going to be for 7 pi 12, right? Then you just go back to your unit circle. 7 pi 12 is a little more than half. We're in quadrant 2. So sine of that value is going to be positive, because sine is positive up here. If I did the same thing but with cosine, my answer would be the negative, right? So that's not saying that it's always plus or minus. It's based on whatever u over 2 is, will dictate whether it's a plus or a minus. Find the exact value for sine of 112 degrees, 30 minutes. We've got find the exact values for sine of 112 degrees, 30 minutes. And this is not a nice number, right? This actually is 112.5, which is half of 225 degrees, which if you recognize your angles here, 180 plus 45 is 225. So this is kind of going to be the same, the exact same actually, as 5 pi fourth, just for radian usage. But just as a reminder, if you need your calculator to type that in and figure that out, this is what we're doing here. Sine of 5 pi fourth all over 2, because 5 pi fourth would be 225 degrees. So 112.5 degrees is what quadrant? Right, a little more than 90, less than 180. So this is going to give us a plus square root of 1 minus cosine of u. Well, now we plug in the 5 pi fourth, right? So you're plugging in the numerator of that half over 2. And now this is a simplifying it. Okay, 5 pi fourth, right, that's actually down here, which is going to be a negative root 2 over 2, negative root 2 over 2 for both values. So plugging it in, and now we know it's positive, I'm just going to leave it, right? Like, we know what it is. So 1 minus negative root 2 over 2 all over 2. I'm going to simplify the numerator here. So this is going to get to become 2 halves. So then I'm going to be left with 2 plus square root of 2 all over 2 over 2 again. Goodness, right? Still in a square root. And then for simplifying reasons, I don't like a double fraction, so we can either, there's 2 ways to simplify it. I like to just treat this as times half on top and bottom. Because remember, divide by 2 with fraction becomes times, and then you flip it, right? So those are the same thing. Dividing by 2 is times half. So timesing by half on top and bottom, I get 2 plus root 2 over 4. And now I can do square root of each feet and get square root of 4 is 2. And the top is square root of 2 plus root 2. Looks really goofy, but that is your answer. Again, emphasis is on you need to figure out what the plus or minus is as before you even get into simplifying. You need to figure out if it's plus or minus. And right now I know it's plus, and we're good to move on. Cosine of 5 pi 12. Now a little note, some might say, why don't we do cosine of 3/12 plus 2/12? We can do that. However, with this one, we're getting our u over 2 practice in, so we're going to use that one. So again, 5 pi 12 is half of 5 pi 6. So this is cosine of 5 pi 6 over 2. Now, 5 pi 12 is quadrant 1. So again, cosine is positive in quadrant 1. So even though 5 pi 6 would be negative, we have to consider just this. So now I've got plus, and then I'm doing the same thing, square root of 1. In this case, it's plus cosine of 5 pi 6 all over 2. 5 pi 6 is negative root 3 over 2, 1/2. So plugging it in, and now simplifying the numerator here before we square root anything, we're going to have 2 minus square root of 3 over 2 again. And again, this is this 2. This 2 is from here and here. Times it by half on top and bottom, and then distributing it, right? To get us, we've got square root. I'm just going to split it up to square root of top, square root of bottom. We've got 2 minus root 3 in the numerator, square root of 4 on the bottom, giving us 2 minus square root of 3 all over 2. So square root of 2 minus square root of 3 all over 2. Next, power reducing formula. Notice, again, same thing. We're coming from the same cosine of 2u equals cosine 2 cosine squared of u minus 1. we went from single power to squared. You can go the other way. We can go from squared, if we solve for this piece, to 1. So that's what's happening here. So notice with these formulas that even though we're going from sine squared to cosine singular, the argument is doubling in each one. So rewrite cosine of 4th power of x. This is cosine squared of x times cosine squared of x. And now we're using our formula sheet. Cosine squared of x is what? Right? We're plugging this in for cosine squared of x. So now we got 1 plus cosine of 2u over 2 squared, basically, because the second one's going to be the same thing. I'm sorry, it's 2x because the argument given to us was x. Foiling, we've got 1 plus cosine 2x times 1 plus cosine of 2x. 1 times 1 is 1. We get 1 cosine of 2x. Right, that's what we're doing. Another cosine of 2x. We have 2 cosine of 2x plus cosine squared of 2x. That means we're going to have more work there. All over 4, because 2 is the denominator. So these pieces are fine. This one is not. We need a single power, so we're going to have to do it one more time. So separating them quick, we've got 1/4 plus 2 over 4 will simplify. We could write that as 1/2. We'll do that when we get to the next step. And now we've got plus, substituting again. But this time we're going to go from 2x to 4x. Okay, notice this. I'm now plugging in the same looking piece. There's going to be 1 plus cosine of 4x over 2, all the numerator, because we're using the power reducing formula again. And now simplifying this piece, again, this is the same as divide by 4 is the same as times 1/4. And now we've got 1/4 plus cosine of 2x over 2 plus the 4 goes to this part, and now we can separate. So 1/2 times 1/4 is 1/8. And then cosine of 4x over 8. And now just a little bit of simplifying. We have 1/4 plus 1/8, right? 1/4 is 2/8, 2 times 2. So 2/8 plus 1/8 is 3/8. And then just continuing, plus cosine of 2x over 2, plus cosine of 4x over 8. And there is our power reducing formula in action. Next, we've got sine squared times cosine squared. I'm going to have you try this one out on your own. So pause the video, and then once you're done, and your final answer, simplified, was 1/8 minus cosine of 4x over 8. Walking through it. Sine squared of x is 1 minus cosine of 2x over 2. Cosine squared is 1 plus 2 cosine of 2x over 2. So those are conjugates. So a minus b times a plus b is going to be a squared minus b squared. And then we just have to, again, expand the cosine squared of 2x to becoming 1 plus cosine of 4x over 2. Divide by 4, times by 1/4 on top and bottom to get 1/8. Negative, right? The negative distributes to both pieces. And then a minus cosine of 4x over 8. 1/4 minus 1/8 is 1/8. For a final answer of 1/8 minus cosine of 4x all over 8. Last set of formulas here, we're going to have product to sum and sum to product. Right? In this case, they found out how to solve for sine u, sine v through a combination of fractions and cosine u minus v formulas, cosine u plus v formulas. So how these are going to work is it's going to say given sine of 5 theta, cosine of 3 theta, rewrite this product to sum as a sum, right? Because we start with a product, so it wants us to end with a sum. So using our formulas, you're looking for which one has sine, cosine. So in looking at the formulas here, this one seems to closely match. Sine cos v is the third one, where we've got the formula is going to be half sine u plus v plus sine u minus v. Right, so the first idea is to get this down. U is 5 theta, V is 3 theta. So filling it in, either in or below or above, 5 theta, 3 theta, 5 theta, 3 theta, and then we can just simplify it from there. Right, so half of sine of 5 plus 3 is 8 theta, plus sine of 5 minus 3 is 2 theta, and then we can either leave it like this, or we can distribute the half. So that's okay, or distributing the half sine of 8 theta plus half sine of 2 theta. Either one of those work. I would say this looks a little more like a sum than this. This still looks like a product. So to be totally honest, that looks like what our final answer should be. Oh, I'm missing a 2 here. 2 theta. Okay. Next, 5 cosine of 2x, cosine of 3x. Now, don't get thrown off by the 5. We're still looking what matches this pattern, and then we're just going to distribute the 5 in the end. So this is going to be 5 parentheses, and the double cosine matches this, half cosine of u minus v plus cosine of u plus v, and then just filling it in, 2x, 3x, 2x, 3x, and we get what's half. And now 5 times half is 5 halves. So we can do that multiplying first here. But we got 2x minus 3x is going to be negative x. 2x plus 3x is going to be 5x over here. Okay. And then lastly, cosine eats a negative. So this negative is going to go away, and we get 5 half cosine of x plus 5 half cosine of 5x. And there's our final answer. One last problem type is the sum of the product. So now we're going to have this kind of adding thing, switching it into multiplying. And we get, find the zeros of the function between 0 and 2 pi. So cosine of 2x minus cosine of 6x. And again, this is a formula sheet one where you're looking at your formula. Which one does it match? This is cosine u minus cosine b, which equals negative 2 sine of u plus v over 2 times sine of u minus v over 2. And then we just fill in the u and v's and simplify. So u is 2x, v is 6x. And then plug it in. Negative 2 sine 2 plus 6 is 8x. 8x divided by 2 is 4x. Right, the top of 8, and then you did the dividing. Over here, we're going to get negative 4x, negative 4 divided by 2 is minus 2x. And then we deal with the negative sign. This negative is going to come out front, which is going to give us a double negative, which will leave us with positive sine of 4x, sine 2x. And that is our final question of the lesson. If you have any questions, feel free to ask, and the homework around there. Also, we're looking for exact answers using algebraically only, meaning no graphing, even if the question asks for it.